Hi, it's Pushpa again. We're coming up towards the end of the day, but we got a few more interesting panels to bring you. My next one is the overtime panel for building tech. So I have Shaker with me, our JLL Director of Innovations, and then I also have Chad Curry, who is the Managing Director of NAR Center for Realtor Technology and CRT Labs, because I think I want to visit.
Yeah, so we actually have an innovation lab, quite like Shaker does. It's at our headquarters at 430 North Michigan. We're looking at renewable energy, IoT, blockchain, aquaponics, community gardening. Aquaponics are when the waste from the fish go up into a little bed of plants, feed the plants, the water's filtered by the plants.
Oh, I still want a field trip here.
You're more than welcome to. We love having people. But we also design boards like this. This is an environmental quality sensor I was talking to Tim about earlier. We're doing about 9 different metrics with this.
May I?
Yeah, please.
I mean,
that's a prototype.
You're not going to break anything, right?
Yeah, it's totally fine.
Okay.
But it's radio frequency, so it can communicate with a little hub, like a Raspberry Pi right now. But it's
There's so many tiny.
Yeah.
I don't know if we can't show that, but there's so many tiny little bits in there.
But there's 9 sensors on here. We can do a total of 10 different things with it.
And so what does your center do?
So we're looking at where emerging technologies are coming into real estate for commercial and residential and what they mean for the future of our industry. So just a very simple goal.
Exactly what we're here today about.
So I mean, we have 3 engineers. We have a hardware engineer, software engineer, and an engineer that's between both of those. And we have a project manager and a user experience person and myself. We're looking at things like creating plant books, what plants can actually mitigate VOCs.
Plant books?
Yeah. So a book on what plants mitigate VOCs and how to...
And what's a VOC?
Volatile organic compounds, I'm sorry. So we identify the problem with this and then we figure out a way to take care of it.
Let's go back. Volatile what?
Organic compounds.
Okay.
Formaldehyde, benzene, trichloroethylene. These are things that come from press board, particle board, our furniture, our carpets, yeah. So
because other people where I talked to when they were talking about air quality, they were like, you know, if someone complains about air quality and it's because there's a certain perfume that's too strong, this is a lot heavier stuff.
Yeah, but this is also
volatile
what affects
organic compounds.
It affects our health. It affects the way we perform. So we want to be able to find that, but also take care of it.
Love it. All right, we're going to have to come back to that topic.
Awesome.
Let's talk about the panel that you were both just on. What were you talking about for building tech, right? What kinds of things were you talking about in terms of smart buildings? Must have been top of the list, right?
Yeah.
So what technologies hold the most potential to change the way that buildings are managed?
Would you like to go?
Sure. Let's start with the ones that we already are using today. It's the lighting sensors that automatically switch on when you walk in. The smart thermostats, which automatically starts controlling the temperature once it sees that there is presence in the building. And room booking apps. So meeting rooms.
Yeah, conference room bookings.
Conference room bookings. And analyzing a bigger conference is how are the conference rooms being used? Are bigger rooms used by fewer people or smaller rooms used by too many people? So all these analysis can be done. We can know more about where people are spending their time in their office, which areas are more crowded, do we need more coffee machines, or is printer enough, or do we need even a printer if nobody is using it? So these are the things that we are moving towards.
Yeah, and I think predictive and preventative maintenance too. So looking at how many times the elevator goes up in a day, what's that motor performing like, right? Does it actually get people to the 4th floor in the same amount of time it did yesterday? So those types of things.
Oh wow, yeah.
Yeah, so those types of things can help us make changes in the way we take care of a building. So one thing I've noticed a lot in downtown Chicago, escalators have been going out left and right? For some reason, I don't know why. I'm serious.
You mean going down?
Yeah,
like not being replaced.
Well, when they go,
like stop working.
Exactly right. But when they go down, you still have stairs, as one of my engineers pointed out. So he's right. You know, better than
good luck.
If you're going down, that's not a problem, right? But look at some of the places where you have to go up, and I'm not doing it. I'm finding an elevator.
But there is Washington D.C. is the worst place. Yeah, that's. But anyway, my point is
you're taking the train to another station.
I know. But my point is you know, rather than us just having to deal with that, we can start to know this is the life expectancy for that motor. Right. You know, So that can be taken care of based on the data we're harvesting, just like he was talking about, from watching the performance.
And that's today, though, right?
Yeah, you can do that today.
Through some of the machine learning and then coming up with it. What do you think is coming up?
Well, I think, we're working on the sensor here, but I think the best sensor is the human. And I think we talk about ingesting data into one central point right now, where one person, a building manager, can look at that and the building can respond. But I think at some point, it's going to be like social media for the building, where each person in the building is able to control their comfort levels in a way that doesn't affect, him. And I mean, I'm talking about us sitting this close together. He would stay comfortable in a way that.
You think that can happen?
Oh yeah, absolutely. And actually, there's a company called Hyperchair. Hyperchair.
Chair.
They make a chair that heats at the bottom and the back,
Yeah.
or cools at the bottom and the back, depending on what you want.
So kind of like in your car.
No, I'm talking about yeah, exactly, like the one in your car, but I'm talking about in the office. Yeah. They're a company that exists right now. They came out of the Center for the Built Environment out in Berkeley. But that's, that type of comfort will save tons of money in the future. Because you don't have to worry about heating and cooling an entire space.
Right.
They're finding you can go from 66 to 78 and still keep the comfort level good for everybody. I'm talking about Fahrenheit, 66 degrees to 78 degrees. Whereas right now, if you do temperature control, it's 68 to 72 with traditional methods.
Yeah,
right?
It is.
So imagine the energy savings with that.
I'm the one who's mostly cold.
Well, imagine. Then she needs to be a beta tester for the Hyperchair.
Happy to do it.
You're welcome.
Although in fairness, I live in Miami and work from home, so I do control quite a bit of my own.
That's right.
But happy to test out anything you want to send my way.
Yeah.
And Shaker, what about you? What do you think still has potential to be touched here, or next thing to be impacted in terms of the buildings?
It's about using the data that we already collected with the sensors. Yeah. So we have the data, now we need to analyze the data and find out ways to save. It could be based on are the building being heated before even the people are coming in an hour before. So
right.
if we can find out at what times in what days, what time the people arrive, we can start the HVAC unit right before. Yeah. So there is cost savings there.
Right.
And hoteling. So right now, offices, the newer offices, they don't have resort spots anymore. We are all going with hoteling spots.
Right.
And when it comes to hoteling, and we know that few days there is not going to be much occupancy. Let's say in a building like 1,000 people, if
like Friday afternoon.
Yeah, Friday.
We know nobody's going to be there. Well, if you're
Fridays itself, people prefer work from home,
right.
So probably 40% of the building is occupied. In that scenario, do we have to light up all the floors? Right. We can shut off few floors and have people go to the right floor.
Oh, right.
Yep.
If you don't have assigned seating, then that means that you can go anywhere we tell you to go.
The marketing department and IT department are together because people arrive at the different times.
Yeah.
So, but also with that, you're talking about the internal effects of people arriving at the building, right? But then also, if you talk about the external effects of when does the sun arrive, right? So
the sun?
Yeah.
Okay.
So knowing when the sun is hitting your building at what time of day, that could also affect the way you're heating and cooling the building.
Absolutely.
And cause the HVAC system to react with light detection or the glass to go darker, almost like the transitional lenses.
Yeah.
And the photochromatic, right? And then harvest that sunlight and store some of that energy.
And a lot of what you're talking about will all impact employee satisfaction. People
Definitely.
they wouldn't mind as much being in a building,
Yeah.
or companies might stick around longer, right? Mm-hmm. Let's talk a little bit more about the panel. Now, mind you, I've been here, so I wasn't there. I would have been if I could, right? Definitely wanted to hear what you all had to say, and that's why I'm glad you're here with me now. But Chad, I believe you mentioned gamification.
Oh yeah.
How does that play into workplaces?
I mean,
here?
Because
now you're giving me even more reason to maybe want to go to an office.
Good. Okay. Well, so
I'm not sold yet, though. Remember, I live in Miami. You got a good deal.
Part of it is the way the person interacts with the building. Like, there might be someone who is, using a lot of devices, who's charging stuff. That's a terrible example, but people use less energy or actually walk rather than take the elevator, they walk the stairs up to their office.
And if you track those
exactly
kinds
right.
of activities
Exactly right.
by person and give them points for it and badges and all that kind of stuff.
Absolutely. And also there's...
days off.
Yeah, that's right. They can earn days off.
Bonuses.
You walk a certain amount of miles. Absolutely. That I see is coming in as an amenity. I mean, I think HR departments now are taking advantage of wearable data and holding step contests for their buildings. You know, so I think that's a way to promote a healthy work environment. You've got things like the WELL certification coming online.
The what?
The WELL certification, which is about the health of the people in the building.
Okay.
So LEED is about the health of the build. I'm simplifying here.
Thank you.
LEED is about no. I mean only to make the point, but LEED is about the health of the building, the greening of the building. WELL is about the health of the people in the building. So the light actually supporting your circadian rhythm. Having things like the plants in the building to have some green space for people to go to, not offering sugary drinks, that's part of the WELL standard. Having a place to do fitness, all that stuff. So,
interesting.
Yeah.
Okay. So, we've talked a lot about more of the employee satisfaction side of it. How about in terms of cost savings? How can some of these things, in particular the Internet of Things and that's gathering all the data and whatnot, how does that translate to cost savings?
Let's take simple examples of, we capture data from equipments that are in the buildings, and we know when there is an equipment failure, where there is a call coming in, and we know that the equipment went wrong, we will be able to determine the surroundings or attributed factors which made that equipment go off or not work. So if we find the similar matching scenario in a different building or on a different equipment, similar equipment, we can prevent that failure to happen again here in the other building. So that's cost savings.
So similar to what we're talking about with equipment like elevator, escalator, and that kind of thing, but it could also be the HVAC system or a refrigerator, anything, right?
Yes. And also when it comes to lighting or HVAC or controlling based on the occupancy. So
you have energy savings as well,
yes.
then. Now, what about, Shaker, I heard you talked a lot about the big potential of tiny sensors. What was that about?
So we did a IoT POC in our Lombard office. We played with several different sensors. We used roughly around 55 different sensors.
Okay.
It varied from temperature sensors to multi-sensors. So the multi-sensors that we used detected UV, humidity, vibration, temperature. So it sensed 6 different things. And it all works great, but the problem is these are all battery operated. So once you place a sensor, you shouldn't go back to the sensor to replace the battery. When you do that, you are...
Because you need a sensor to tell you when the sensor's battery is about to be done.
You may not need a sensor to tell you that there are ways to detect if the battery is going down, but then you have to send in a person to fix it.
Right.
That's more expensive than the sensor.
And that's the beacon technology that was supposed to be prevalent a few years ago. That was the big downfall, was the fact that you had to replace batteries all the time. But there are companies like, there's one called Free...
And sorry, just for 1 second, when you say tiny sensors, I should have clarified this. Is that a thing that I don't know about, or are we talking about like tiny because they're tiny?
Small sensors which can go into existing fittings.
Sometimes things mean different things in the tech world. I got to make sure I'm talking about the right thing.
Yeah, and the University of Michigan actually made a sensor the size of a grain of sand called the M-Cubed, which actually uses microwaves to power it, to keep it powered. So it's energy harvesting as well. And they meant it for cancer research. So you put these sensors in a body, you build a 3D model of a tumor, and you can actually get ahead of doing exploratory surgery and understand what that tumor looks like and build a way to actually take it out before you get in the body. But these can be used in commercial settings and residential settings. So you could actually have them embedded in the drywall, right? And they could tell you about the temperature and humidity all along that wall, and the humidity could spike if there's a pipe that breaks behind it, So those are an example of some of the tiny sensors that are coming.
Size of a grain of sand.
Yeah.
So you don't know it's there.
Right.
It's really
actually, yeah. If they drop one on the floor.
I mean, you could have them all over here, and how would I know?
If they drop one on the floor, they let it go because
gone.
they don't know where. Yeah, they don't know where it went. So, but yeah. So
it's not efficient to look for.
Yeah, no, it's not worth the engineering hours to find it, right? But anyway, yeah, I think the smaller sensors are exactly right. And thinking about ways to make them movable too without having to worry about the power line infrastructure. There's a company in London that makes, they're called FreeVolt. They make a radio frequency. FreeVolt?
FreeVolt?
A radio frequency harvesting battery. So all the backscatter, 3G, 4G, and the Wi-Fi power the battery. But there are companies in America doing that as well. So I think that'll make it so you can easily move these moats around and not have to worry about finding that power infrastructure either. It's pretty exciting. I'm excited. Let's talk more.
Well, what are your final thoughts then, if that's the case? Give me one last thing from each of you as it relates to building tech, and doesn't have to be what you talked about on the panel. Just you've been walking around talking to some of the tech companies here today. You're both living and breathing this every single day. What are some final thoughts from each of you?
Can you go first?
Sure.
Oh, all right. So I think the fact that we have these disparate data sets that are currently existing, finding a way to make them easy to consume and display. I think that's the big.
I think you guys need to talk.
I think that's the big thing, right?
So we were talking earlier about the self-serve data
really?
and being able to do that, and some of the stuff that Shaker's team has accomplished.
Cool.
For being able to take all of that and cut it down from days and weeks to minutes.
And then have to onboard that with the data that's coming from things like the Array of Things project here in Chicago, which will do what I said with letting you know when the sun's coming or when the air quality changes or what have you.
Right.
Having that in place and keeping it open, I think, is the way to go. I think our industry, real estate, has learned that closed data sets don't really benefit everyone.
The whole transparency thing,
yeah,
it's
absolutely.
happening.
It's got to be.
Shaker, any last thoughts?
Simplicity. So we need to make
I'm all
things
about
simple.
that.
If we are asking for feedback from people, it's not, we are not going to get it.
Yeah.
So we need to make it simple. Have simple frown happy faces,
Right.
which people can punch.
Right.
No instruction
places.
needed. Well, thank you both. I appreciate it. And you're definitely both experts in your own right here.
Thanks.
I want to talk to both of you more on my next break, so
Awesome.
thank you.
Thank you.
We've got one more video, and then we're coming back with a couple of final thoughts for you to wrap up the day. We'll be right back.
Let's go ahead and submit it without pricing.
If there's a book that's like a.
Hey, I had a business-related question about the business we conduct.
Oh yeah, let's find a room.
I think that you could have synergy.
There's an empty conference room.
Oh, great.
Okay, the conference room just opened. So.